All right, page 3 of the study guide. We're given this table up here that has values of f, g, f prime, and g prime for x equals -1, 0, 1, and 2. And we're going to use this table for both questions 10 and 11. Number 10, all right, we have h of x, which is equal to f divided by g, and we want to find the slope of the graph of h at x equals 2. We want the slope of the curve at a point along the way. That means we want h prime. We want the derivative. All right, let's get h of x derived. That gives us h prime of x. We must use the quotient rule. Bottom d top minus top d bottom all over bottom squared. We want h prime of 2. Okay, so that means we want g of 2. G of 2 is -1. Then we want f prime of 2. F prime of 2 is 5. Minus. Then we want f of 2, which is also 5. And we want g prime of 2, which is 2. All over g of 2 squared. G of 2 is -1. So we have -1 squared. All right, so what's this equal to? -1 times 5, oops, sorry about the crookedness, is -5 minus 5 times 2 is 10, -5 minus 10, all over 1, so that's -15. Number 11. Same idea, same setup. This time we have a of x equal to f times g, and we want the slope of the graph of a at x equals -1. So this is asking for a prime of -1. So again, we have to find the derivative of a. This will be a product rule. Derive the first, keep the second, plus derive the second, keep the first, in some order. So, see if I can get this on the same page. I got to zoom out a little bit. There we go. A prime of 2 will be f prime of, no, sorry, not 2. We want -1. Excuse me, -1. F prime of -1, which is 3, times g of -1, which is 1, plus, now we want g prime of -1, which is 0, so it doesn't really matter what f of -1 is, but we can see that it's -5. So we have 3 plus 0. So our answer is C. And that brings us to D. I'm sorry, D12. I see the D in problem 12. All right. Similar to what we've had before, we have to figure out the values of C and D if f is differentiable at x equals 2. So that means we have to check out continuity first. In order for the function to be continuous, the top piece of the original function must be equal to the bottom piece when x is equal to 2. So we have C times 2 plus D, that's the top piece, and it needs to be equal to 2 squared minus C times 2. That's what that's saying right there as the bottom piece. Okay, well, what can we do here? Looks like we can add 2c to both sides, and if we do that, right, plus 2c plus 2c, we have 4c plus d equals 4. Not much we can do with that at this point, so let's go to the other half. The other half is the differentiability portion, which means we need f prime of x in order to figure this out. We have to derive each of the pieces. the derivative of c times x, wait a minute, that means c is a coefficient. So the derivative of cx will be c. D is a number. It does not have an x appended to it, so it's just a constant. And we know the constant rule says that it will derive to 0. So the derivative of the top piece is just c. And again, that's for x less than or equal to 2. The bottom piece, the derivative of x squared is 2x minus c. And that's for x greater than 2. Put these together. C is equal to 2x minus c. But we know that x is equal to 2. So c is equal to 4 minus c. Add c to both sides. 2c is equal to 4. C is equal to 2. Now head back over here. We just found out that c is equal to 2. So d plus 8 is equal to 4. That means that d is equal to negative 4. C plus d will be 2 plus negative 4.